This is a P1 energy video looking at the efficiency equation. This is an equation that you need to know. And we've got two versions of the efficiency equation, one looking at energy transfers and one looking at power. So it tells us here a hairdryer is, oh, actually let's go back to the equation. So efficiency is the useful output energy divided by the total input. So we've kind of created it as a fraction. Okay, the useful stuff divided by the total stuff that went in. Okay, so the wasted energy is taken away. So if we're told what the wasted energy is, we can work out the useful energy by doing total in minus the wasted, and that gets our useful. Okay, now we could leave this as a decimal point answer. Okay, if it was 100% efficient, we would say it was 1, or we can turn it into a percentage, totally up to what the question is asking for. So a hairdryer is 72% efficient. It has an input energy transfer of 120,000 joules of energy. That might be written as 120 kilojoules, and then we would need to convert it to joules. What is the useful output energy transfer? So useful output, when we rearrange the equation, is efficiency times the total input. Okay, so I've moved this here to over here and I've multiplied it. Okay, you can do that using an equation triangle. So the useful output energy is 72% times 120,000. Now look what I've done here. I've converted that 72% into 0.72. Okay, because I don't want to do 72 times that. It will be a huge number. I want to find out what is 72% of 120,000. So 0.72 times 120,000 gives me a useful output energy of 86,400 joules. If I needed to convert that to kilojoules, I would call it 86.4 kilojoules. Okay, it has to seem logical. The useful out must be less than the total in, otherwise it's just not possible. Let's look at the last equation then, using it in power. So similar equation. Efficiency equals useful power output divided by total power input. A radio has a useful power output of 540 watts and efficiency of 78%. What is the total power input? Okay, so rearrange the equation again. We've swapped these two. Again, if you're not happy about doing this, you can do this in a formula triangle. So the total power input is the output divided by the efficiency. Again, I've done the same thing here with the efficiency. I've taken it out of that percentage form, put it into a decimal form, okay, by turning it into 0.78. So 540 watts divided by 0.78 equals 692.3 watts. Because we were to the nearest watt in the power output, I've rounded it to the nearest watt in the answer. So it's 692 watts is the total power input. Now that needs to be more than the output because some of the output is wasted. So the useful output was 540 watts. So the total input does make sense that it's 692 watts. I'm just doing a quick check there, logic check. Is it right? Hope you found that useful. Thank you.